Hey everyone, so I'm going to go over the video, or this is the video for freshwater ecosystems. So these are the set of notes that we started when I was here like last week, and then I told you to finish them on your own. So I'm trying to go back over these notes so you actually know what's going on instead of blindly copying them. So the first thing I want to talk about is freshwater ecosystems. Alright, so there are two different types of freshwater ecosystems. And when we talk about freshwater ecosystems, we're talking about ones where the sodium or the salt content is below 1%. So anything that has a sodium or sodium chloride percentage above 1% is technically considered marine or saltwater or whatever. Alright, so the first type of freshwater ecosystem that we're going to talk about are actually called lotic. Alright, and lotic systems, they flow. So I've drawn this picture here, to show you that, they flow. So the way that I remember this, low, tick, and flow kind of do the same thing. They have the same O sound. Alright, so examples of these include rivers, streams, tributaries, basically any type of water that is flowing. And we'll talk about these things called meandering streams towards the end of this video. But you just need to know the difference between the two. Alright, so lotic means that they flow. Lentic, on the other hand, those are the ones that are, these are things like lakes, reservoirs. Okay, so things that do not, you wouldn't think of as flowing. Alright, they're usually kind of like a pond. Anything that is stationary, and stationary just means that it doesn't flow. Alright, so I drew these two pictures. This one is flowing, this one here is not. Alright, so lakes, reservoirs, and ponds are examples of things that do not flow. Alright, the next thing that we need to talk about is photic versus aphotic. Alright, so when we're talking about the photic zone or photic, anything that has the word phot in it, usually we're talking about light. So the photic zone is the zone of a lake, stream, or pond where light penetrates. Alright, and over here to the right I've drawn this picture here to show you that light is reaching this shallow area. This is probably towards the coast of a lake or a pond or something like that, or even a reservoir. So since we have a lot of light here, we are actually going to have a lot of photosynthesis occurring. Right? So there's a lot of photosynthetic organisms that are living here. Maybe they're living in the water, maybe they're slightly submerged, so maybe there's some algae that are living in here somewhere, and maybe there's some plants that are growing on the ground or on the bottom of this lake here. Okay, so something like that. So light is getting to them, and they can grow in that kind of thing. Alright, so there are some plants that are growing on the bottom. Alright, the next zone is the aphotic zone, and I wrote it in black here to indicate dark. Alright, so this is a zone where light is absent, or it doesn't penetrate, basically. Alright, so the way that I like to think about this is you have an upper layer portion here where the sun is reaching, and as you go down deeper and deeper, there's this darker blue water here where this would be the aphotic zone, and this here would be the photic zone. Okay, so the sunlight is penetrating up here into the photic zone. The aphotic zone is the dark depths of a lake or a reservoir. And I think about Finding Nemo, where they go down to the deep, dark depths of the ocean and they run into that, the anglerfish that has the light and stuff like that. So, photic versus aphotic. So in the photic zone, we're going to have a lot of photosynthesis, which leads me to my next topic, which is talking about dissolved oxygen and the depth of water in like a reservoir or a lake or even really the ocean. So you may see this graph on a test. Hint, hint. So what's going on here is, so we talked about this here, where we talked about there's the photic zone versus the aphotic zone. And since the light is penetrating here, there's a ton of photosynthesis. And since there's a lot of photosynthesis, there's also going to be a lot of oxygen in the water. Okay? So if we look at this graph here, and this is showing you the depth at the top. So the depth starts at 0 up here, which is kind of odd. Usually graphs have 0 down here at the bottom for both of them. So anyways, I was talking about how as you're at the top here, the depth is 0. So at the top here, this is most likely still the photic zone here. So there's most likely this upper portion here. This would be the photic zone. And since there's light in this upper region, we've got a lot of oxygen dissolved in the water. So if you look down here at the bottom, it says there's 7.5. This is parts per million of oxygen dissolved in the water, and this is mostly due to the light. There are photosynthetic organisms that are producing oxygen and putting it into the water. As you go down deeper and deeper into the depth increases, then you don't have any light. It's the aphotic zone, and you're going to have less photosynthetic organisms, and the O2 will eventually decrease to almost 0. Okay. But as we have O2 over here, CO2 is this green line over here. So as CO2, as we increase in depth, CO2 actually increases in concentration. And the reason for this is because as we go down deeper and deeper into the depths of the lake or the reservoir or whatever, then there are going to be more things that are putting off CO2 from cellular respiration. And there's not going to be photosynthetic organisms like phytoplankton and stuff taking it out of the water. So as you increase depth, the CO2 here is going to increase. As you increase depth, the O2 decreases. Okay, so again, this is the photic zone. Photosynthesis is happening. Photosynthetic organisms are putting O2 into the water. As you increase the depth, the CO2 actually increases because there are more, animals doing respiration and stuff like that. All right, so let's talk about the next topic that I wanted to talk about, which is the 3 different types of lakes. So we've talked about the lentic systems, and we talked about there are different types of lakes. So there are basically 3 different types of lakes, and the 3 different types of lakes are oligotrophic, mesotrophic or mesotrophic, and then eutrophic. Alright, so the first one is oligotrophic, and these are usually the ones that are the youngest. Alright, so I'm going to write youngest, usually steep banks, usually low nutrients. Alright, so I try to show here that the water is actually colder and it doesn't have a lot of nutrients in it, so it's like a bright crystal blue. So an example of this one would be like Lake Jocassee. I don't know how to spell Jocassee, so I'm just going to do my best. Alright, so Jocassee would be this one here. Alright, so mesotrophic is kind of like the middle one, the mid version between oligotrophic and eutrophic here. So we've got mesotrophic, and mesotrophic usually have highest biodiversity. So we've got highest biodiversity, medium level of nutrients, and these are usually the ones you want to swim in. These are the ones you want to visit. So recreation, I'm going to put that here. Alright, so an example of this one would probably be Lake Hartwell. Alright, Lake Hartwell has been around for a while. It's got a pretty good set of nutrients in it. So for this one, I made the color of the water kind of like a bluish green color. So there's a lot of nutrients in the water, and you've got a lot of biodiversity. So there's probably a ton of fish like living in here, although you can't eat the fish in Lake Hartwell due to PCBs, but that's a story for another time. Alright, so again, you've got some fish living in here, and you've got some plants, and you've got really high biodiversity. Then we get down here to the eutrophic lakes. And the eutrophic lakes are usually the oldest ones, okay? So usually oldest in terms of time or geological time or whatever. Alright, usually these have brown, green, murky waters, okay? And these are the ones that you usually don't want to swim in, and a lot of times they have a lot of algae living in them. And we'll talk about eutrophication and cultural eutrophication here in a second. So eutrophic are usually in the beginning stages of eutrophication, where there's some sort of increased nutrients, where algae are growing out of control, and a lot of times this is going to be accelerated by fertilizers as they run off into the lake here. The algae bloom, and eventually they could cause hypoxia, but it's not a definite thing. All right, so this one would be like Lake Greenwood, and Lake Greenwood has been experiencing a ton of algae growth lately because fertilizers are running off into the Reedy River and the Saluda River, I believe, and they're running into Lake Greenwood, which is causing giant algae blooms. All right, so the algae eventually will sink to the bottom and they'll kill off a lot of the fish and so on and so forth. All right, so we've got oligotrophic, mesotrophic, and then eutrophic. All right, the next thing we're going to talk about are the zones of a lake. And again, we have, so I drew this beautiful picture here. So we've got sunlight that is reaching here. Okay, so this would be like the photic zone here. So the first zone that we need to talk about is called the littoral zone. So I put all four of them right here. The littoral zone is going to be, usually it's around in here, the littoral zone. The littoral zone is going to have really shallow waters. Usually this is where you would wade in if you're going to wade into a lake or something like that. And it usually has the highest amount of biodiversity. When we get out here into the open water that still has sunlight, it's still in the photic zone, that is going to be the limnetic zone. Alright, so the limnetic zone is this open ocean, or not open ocean, open lake or open reservoir where we still have sunlight, and there's photosynthetic organisms here in the water that are producing oxygen and stuff like that. Alright, so those are supposed to be algae. Alright, then we've got the profundal zone, which is kind of here, and I don't know if you're going to be able to see this, but I'm going to write profundal zone is down here, kind of where it's like the open water where there's no sunlight. And then we've got the benthic zone, which is the bottom. Alright, so the benthic zone is basically the bottom. Okay? So those are the four different zones of a lake. We've got the littoral zone, which is the shallow area. We've got the limnetic zone, which is the open area that still has light, still got some photosynthetic organisms. We've got the profundal zone, which is an aphotic zone, meaning there's no sunlight. And then we've got the benthic zone, which is basically the bottom of a lake. And sometimes the bottom is really hard to get to, like in Jocassee. Alright, so the next thing I want to talk about is how a lake can change based on temperature and the different seasons, which is called thermal stratification. Alright, so you did something like this on the lakes FRQ, if you remember that. Alright, so this is thermal stratification of a lake. So what happens is this graph is showing you temperature and depth. So let's say that during the summer, we have water that is close to the surface here of a lake. Let's say that this is just showing one lake. Let's say it's Lake Hartwell. So this epilimnion up here at the top is going to be the water that is interacting with the atmosphere. It's being heated up by the sun, all kinds of stuff like that. So it's about, I would say, 28 degrees. This is Celsius up here. All right, so 28 degrees Celsius up here. And usually humans feel most comfortable around 25 degrees Celsius or so. So the epilimnion is this upper layer. Okay, so upper layer of a lake. It can really be any body of, like, standing body of water. Upper layer of a lake in contact with sun and atmosphere. And since it's in contact with the sun, it's going to heat up and the temperature is going to be higher. It also has high amounts of O2 because we're going to have photosynthetic organisms, and it's also going to be able to interact with it's going to create waves, and that's going to dissolve ocean or oxygen into the lake water. All right, so after we have this, there's this rapid change in temperature because it's no longer getting heated up by the sun and it's no longer interacting with the atmosphere. So this thing is called the metalimnion, and some people may also call it the thermocline. So this one is the rapid temperature change. And the reason for that is because it's not interacting with the sun, it's not interacting with, the atmosphere, it's not getting warmed up, that kind of thing. All right, after you get down here past the thermocline or the metalimnion, we've got this last thing called the hypolimnion. And down here, the water is all one temperature. So water is all one temperature. All right, and usually it occurs, after about 20, this is meters over here, so about after 20 meters, there's about 60 feet. So this is not due to, so if you've ever been in a lake and you feel like a warm spot or a cold spot, this is not what we're talking about. We're talking about the bottom depths of the lake where all of it is just one temperature. All right, so the water is all one temperature. Usually the CO2 levels are high. Okay. So CO2 levels are high, O2 levels are low because we've got a lot of respiration going on down here. So I'm going to put high respiration. So we've got a lot of respiration going on. Down here we have low photosynthesis, and the reason for that is because there's no sunlight down here. All right, so what happens is during the winter and the summer, the lake will basically turn itself into this. It will have an epilimnion, it will have a metalimnion or a thermocline and a hypolimnion. If we are talking about in the fall and in the spring, what's really interesting is that actually this lake will undergo what they call fall overturn or spring overturn. And basically what this is in the spring, this entire lake will just turn one temperature. Because if it's the summer, the water up here as it moves into fall will cool down, and eventually it'll move backwards and it'll look just like one giant line here. All right, so fall overturn and spring overturn are where water temp in a lake becomes uniform. And then when I say uniform, I mean it's all one temperature. All right, and what happens is this thing called overturn, where the hypolimnion, or the water that is down here, so water at bottom, moves to top, and vice versa. All right, so the water that is down here, since it's all one temperature now, it'll start mixing. And this water, so the water that is down here, will move up to here, and it takes nutrients with it from the bottom, kind of like an upwelling in an ocean. And then the water that is up here will move down here, and it'll take oxygen with it. All right, so it takes O2 with it. Okay, so it's actually a really interesting phenomenon, and whenever it's winter or summer, it'll stratify itself, or it'll have these three distinct layers. But when it is fall or spring, they're going to have basically one uniform temperature throughout the entire lake. All right? So the next thing that I want to talk about is everyone's favorite topic, which I've mentioned a million times. And if you haven't guessed it yet, it is cultural eutrophication and hypoxia. I know, your favorite subject. All right, so let's say that this is a lake down here, and this is like the shore and whatever. All right, so let's say that we've got, this is a farmer's field. So we've got some crops. We've got some crops here. All right. And I know my drawings are amazing, and I should have been an artist, but whatever. All right, so these are all basically crops. I'm going to put farmer's field here. All right, and in this farmer's field, he's trying to grow some soybeans or maybe something else, maybe some corn. and it's not growing as much as he would like it to. So he's going to add some fertilizer. Ooh, good for him. So let's say that he puts some fertilizer onto his field, and he says, this is great. I'm just going to keep adding more, right? Because more is better. So he adds tons of fertilizer onto his field. But uh-oh, there's a rainfall event. All right, so now it starts to rain. I'm going to try to draw some raindrops here. All right, so it's drawing some raindrops. Let's draw a cloud here. All right, there's some rain. And uh-oh, what happens? This fertilizer runs off into the water here. Let's also say that he had some cows too. Ooh, good. He's got a couple of cows here too. He had some cows here, and they were, they're just going everywhere. And some of the manure from that goes into the water here as well. So we've got some manure here that runs off into here. So that's nice. And what happens is the manure and all the fertilizers contain nitrates and phosphates. So fertilizers and manure contain nitrates, and nitrates are NO3, and phosphates, PO4. Alright, so they run off, fertilizer and manure run off into body of water. And the algae that are already living in the water, they get really excited because they have been limited by the amount of nitrate and phosphate in their water. So they're here, they're just hanging out here, and then they get all of the fertilizer and all of the manure, and they start growing like crazy. They start multiplying, and these circles are representing algae. They were once limited by all of the nitrates and phosphates that were in their water, but since we added tons of them, now they have tons of algae bloom. All right, and these algae, they're so excited. And eventually what's going to happen is the water will start to turn like this green color because they are producing so many, so much algae, that kind of thing. But guess what happens? Whenever the nitrates and phosphates run out, some of the algae is going to have to die. And when the algae die, it basically causes the algae to float to the bottom. So the giant algae bloom gets out of control. And eventually this will start blocking out all the sunlight for all the things underneath it. So then there may be some plants down here at the bottom that could get some sunlight, but now all the algae is basically just blocking out the sun, which is it's really sad. So then after that, since there's just such intense competition, some of the algae will die. Insert sad face here. And then some of the algae will then start to sink to the bottom. And as the algae sinks to the bottom, bacteria that are at the bottom say, oh my gosh, I'm so excited, we now have tons of food. Alright, so as it sinks to the bottom there, these bacteria that are at the bottom, they start eating it. So these little black dots are like bacteria here. Alright, they start eating up the algae, and they start using up all the oxygen in the water. And as they start using up all the oxygen in the water, the fish here, they start to swim, they're happy, but then, they swim into a, you guessed it, hypoxic dead zone. Alright, so here's the hypoxic dead zone now. So I'm drawing here. hypoxic dead zone. Alright, and when the fish swims into the hypoxic dead zone, so let's say there's like a giant fish over here, and again, I'm terrible at drawing, so you're going to have to bear with me. Alright, there's a dead fish here, because, you know, and then he'll sink to the bottom, because he swam into that hypoxic dead zone. Okay? So again, it started out with the fertilizer in the farmer's field, and also the cows, and it's just very sad. And it usually causes a giant fish kill. Alright, so now we can move on to something else that's actually probably a little bit more, you know, happy or happier. Alright, are these things called meandering streams and oxbow lakes. So what's really interesting is that the normal natural way for a river or a stream to flow is through these, like, I want to say sigmoidal, but that's kind of a big word. So these S-shaped curves, all right? So if you let a river, like, just, you know, to its own devices, eventually it will start to look like this. And as it looks like this, what happens is over time, the S shapes will get more and more pronounced. And eventually what's happening here is that these two banks will start to connect, basically, and they'll converge, and more on that in a second. So why is it the natural, you know, natural progression of these things for them to flow like in these S shapes? One, the S shape allows the river to basically get rid of excess sediment. So it deposits it along the thing. So if you've ever noticed, usually the stream goes like, the water flow is the strongest or is the quickest out along here, as it goes from here to here. And as it does this, the water is basically eroding the sides of the bank. Okay? So as it erodes the side of the banks, it gets rid of excess energy. And it eventually will start to, you know, almost connect like this. And then it will form this thing here, which is called an oxbow lake. So oxbow lake. And an oxbow lake is basically where these little sigmoidal things connect. And these sigmoidal things are actually called meanders. Alright? And these are called meandering streams. Alright? So if you're interested in looking up, you know, some case studies about meandering streams and stuff like that, then you can look up what happened when they tried to basically channelize a river that flowed into the Florida Everglades. So they attempted to just basically make the river run straight, and when they did that, they actually got a lot of buildup of sediment, and they had a ton of erosion of the sides of the banks. Alright, so again, we've got these streams that meander just naturally like this. And what happens is eventually it erodes the sides of the banks, where it will then start to look like this, where this is almost touching. And eventually it will touch, and it'll turn this into this thing called an oxbow lake. Alright? So if you have any questions, or hopefully I covered everything, I'm going to scan these sheets in and post them on Google Classroom. So if you have any questions, please let me know.